Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Nurfahana Fatisha binti Kamaruddin, and this is my group member, which is Nur Amirah Maizurah binti Maizun, Nurina Atira binti Nasir, and Nur Kaisara binti Abu Talib. So in this video we will explain about chromatography and cosmetics industry. So what is chromatography? Chromatography is a laboratory technique used to separate mixtures of substances into their individual components. It works based on differential partitioning between a stationary phase, which is often a solid or liquid supported on a solid, and a mobile phase, which is a liquid or gas. Next, there are several terms of chromatography. The first one is stationary phase. It means the samples are in static part to absorb the components that are being separated where the solvents and analyte or components travel through it. After that, another term of chromatography is retention time. The time it takes for a particular compound to travel through the chromatographic system from injection to detection. And the last one is mobile phase. That means a fluid have a moving part, the solvent or gas that moves through the stationary phase carrying the sample components along with it. Chromatography encompasses several types, each suited to different applications and separation requirements. The first one is gas chromatography, ideal for separating and analyzing volatile compounds such as hydrocarbons, alcohols, fatty acids, and pesticides. Widely used in environmental analysis, forensic science, and quality control of food and beverages. After that is thin layer chromatography. The mobile phase is a solvent or mixture of solvents that travels up the plate via capillary action. In thin layer chromatography, the stationary phase is a thin layer of material on a plate, and the mobile phase is a liquid that moves up the plate. When you apply a mixture to the plate, different parts of the mixture interact differently with the stationary and mobile phases. This causes them to move up the plate at different speeds. Thin layer chromatography is used in drug analysis, food chemistry, and cosmetics industry.
So for theory of chromatography, which our focus is in cosmetic industry, is thin layer chromatography helps us make sure cosmetic products are labeled correctly and meet all the safety standards of the cosmetic industry by identifying and separating the different color components that are used in these formulations like pigments, dyes, and more. By looking at the different color components, you can make sure their product maintains consistent quality and formulations in every product. Thin layer chromatography helps you in identifying preservative in the cosmetic industry like parabens and anestra in your cosmetic products that may cause harm to the skin and health. You can check the formulations of cosmetic products to understand the elements and compounds used in them and their quantities to make sure they follow all the necessary rules and regulations properly to ensure the safety of use for that particular product. You can monitor the preservative levels, use of additives, and colors that are used in the products. But thin layer chromatography can be used for a number of tasks, such as the analysis of sunscreen ingredients, the confirmation of the presence and concentration of UV filters for the best possible sun protection in the cosmetic industry, the analysis of complex lips product formulations, and the analysis of creams and lotion formulations. So the theory of thin layer chromatography is thin layer chromatography is a technique used to isolate non-volatile mixtures. The experiment is conducted on a sheet of aluminum foil, plastic, or glass which is coated with a thin layer of adsorbent material. The material usually used is aluminum oxide, cellulose, or silica. So next is principle of thin layer chromatography. Thin layer chromatography is like other chromatographic techniques. Thin layer chromatography depends on the separation principle. The separation relies on the relative affinity of components towards both the phases. The compounds in the mobile phase move over the surface of the stationary phase. The movement occurs in such a way that the compounds which have a higher affinity to the stationary phase move slowly, while the other compounds travel fast. Therefore, the separation of the mixture is attained. On completion of the separation process, the individual components from the mixture appears as spots at respective levels on the plate. Their character and nature are identified by suitable detection techniques. So for techniques of thin layer chromatography use is first we cut the plate to the correct size and using a pencil and gently draw a straight line across the plate approximately 1 cm from the bottom. Do not use excessive forces when writing on a thin layer chromatography plate, as this will remove the stationary phase, and it is important to use a pencil rather than a pen because ink commonly travel up the plate with the solvent. Number 2, by using thin layer chromatography pipettes, apply spots of lipsticks to the line. Make sure enough samples is spotted onto the plate. This can be done by using the shortwave UV. A purple spot should be seen. If the spot is not visible, more sample needs to be applied to the plate. If a standard of the target compound is available, it is good practice to produce a cold spot by spotting the standard onto a spot of the unknown mixture. This ensures the identity of the target compound. Number 3, place the plate into the chamber as evenly as possible and lean it against the side. Never allow the bulk solvent to rise above the line you draw. Allow capillary action to draw the solvent up the plate until it approximately 1 cm from the end. Never allow the solvent to migrate all the way to the end of the plate. Number 4, remove the plate and immediately draw a pencil line across the solvent front. And the last one is use a shortwave UV light and circle the components shown with a pencil. So for the main objectives of thin layer chromatography in this experiment is to separate the components of a mixture using a thin stationary phase supported by an inner backing. So for the lipstick analysis in thin layer chromatography, the first one is pigment identification, which thin layer chromatography can help identify the types and amounts of pigments used in lipsticks to ensuring consistent color and the quality of lipsticks. Number 2 is dye detections, which thin layer chromatography can detect the presence of dyes which can affect the color and stability of lipsticks. And number 3, wax and oil analysis. Thin layer chromatography can analyze the types and amounts of wax, such as beeswax and carnauba wax, and the amounts of oils like coconut oil and lanolin that used in lipsticks, which affect their texture and consistency. Number 4, preservative detections, which thin layer chromatography detects the presence of preservative such as parabens, which can affect the safety and shelf life of lipsticks. And the last one is moisturizer analysis, which thin layer chromatography can analyze the types and amounts of moisturizers such as vitamin E and aloe vera that use in lipsticks to provide hydration and nourishment to the lips.
Materials that we use for this analysis is jar wet plate, lipstick sample, branded and local, TLC plates, mobile face or solvent face, clean cotton piece, sterile scissor, fine capillaries, ruler, pencil, Todin pellets, tighter plates, graduated cylinder, gloves, and protective mask. There are 12 methodologies for this analysis. First, preparing cloth. Wash a piece of cotton cloth with detergent, hot water and dry it with heat. Second, preparing samples. Cut small 2 cm pieces of cloth and rub lipsticks onto them. And third, organizing samples. Place these thin cloth pieces into label bowls. Step 4 is extracting stains. Use a solution to shake each ball for 5 to 10 minutes to remove lipstick stains. Step 5 is preparing TLC setup. Gather a jar with a lid, filter paper, and a TLC plate. Handle the TLC plate by its edge to avoid touching the silica layer. Step 6 is marking TLC plate. Use a pencil to draw a line 1.5 cm from the bottom of the TLC plate. Label the top with numbers 1B, 2B, 3B, 4B, 5B, 6B for branded lipsticks, and 1L, 2L, 3L, 4L, 5L, 6L for local lipstick. Step 7 is applying lipstick samples. Use a capillary to place small dots of each lipstick sample along the bottom line on the TLC plate under their respective labels. Each dot should be about 0.2 cm in diameter and dark enough to be easily seen. Step 8. Preparing mobile face. Use a pipette to pour the mobile face solvent mixture in a ratio of 4:12:4 into the jar until it reaches about 0.5 cm deep. And step 9 is setting up the TLC plate. Carefully insert the TLC plate into the jar, ensuring the end with the lipstick dots in above the mobile face. Secure the jar lid. Step 10. Developing TLC plate. Allow the mobile face to rise up the TLC plate until it reaches within 1 cm of the top, typically 5 to 10 minutes. Monitor closely to prevent it from reaching the very top. Once done, remove the TLC plate and mark the solvent front with a pencil. Step 11. Measuring distance. Measure and record the distance the mobile face traveled from the pencil line to the solvent front. Also, measure how far each component of the lipstick moved from the pencil line in centimeters. Record this measurement in a data table. And lastly, calculating RF values. Determine the RF value for each lipstick component. To calculate RF, divide the distance traveled by each lipstick component from the pencil line by the distance traveled by the solvent.
So hi, I'm going to continue for the results based on the images that I've attached, figure 10. The experiment is a TLC, which is a thin layer chromatography of different lipsticks. The different color or pigments present in each lipstick have migrated at different rates on the paper, leading to the separation of the colors. The pigments are then viewed under iodine fumes to make the separated colors visible and easy to identify. This method can help identify the individual components of lipstick, which can be useful for comparing different brands or identifying potentially harmful ingredients. So hi, from table 1, we could conclude that similarities in HRF values, unique combinations of HRF values and other factors for us to consider when we are buying a lipstick. So the HRF values of pigments in different local lipstick brands showed similarities with some overlap between values. Notably, the HRF values of 13 is common to sample 2, 3, 4, 5 and 6L, while the HRF values of 37 is shared by samples 1, 2 and 4L. So the next one for the unique combination of HRF values, although there may not be a significant difference in HRF values among local brands, each sample has a unique combination of HRF values. This suggests that each brand may have its own distinct formulation or compositions, even if the individual HRF values are similar. So other factors for us to consider when buying a lipstick is that it's essential to remember that HRF values are just one aspect of lipstick's compositions. Other factors such as color, texture, and ingredients may also vary between brands. These differences could impact the overall performances and characteristics of each lipstick. So for the table 2, it shows the result of local lipstick brands. So the result of the local lipstick brands that are presented, notably each sample exhibited a unique compositions with the number of pigments ranging from 1 to 2. The HRI values varied among the samples with values ranging from 2 to 25. However, a key finding emerged: there is no significant difference in the HRI values among the well-known local lipstick brands under study, suggesting a consistent composition across these brands. So it was proven that no significant difference in HRI value was found among the well-known local lipstick brands under study.
In conclusion, chromatography is essential to the cosmetics industry to guarantee the safety and quality of its products. It improves the components analysis, contamination detection, and formulation stability over time. Companies can meet regulatory requirements, detect allergies, and maximize product efficacy by employing chromatography procedures.